Good day. We're looking at PowerPoint. This is basic stoichiometry. We're trying to gradually build the information so it makes sense. The last video looked at mole ratios. That's one component of straightforward stoic. So basic stoic is going to be the first half of this section. And it's something you have to dominate. It's not hard if you follow the recipe. We've had students in the past who are really good at yelling out three words. Balanced chemical equation. They would scream it. We'd have people wandering down the halls freaking out, wondering what it was about, but they yelled it. So you always remember in stoic, you need a balanced chemical equation. Then you look at the question and you write down all the information that you know that the question gives you. Then you're also looking for what's the unknown, where you're trying to head. So in other words, it's like plotting out a course with an ancient thing called a map. Step 3 says, if we have mass, we've got to get in moles. If we're given volume and concentration, we've got to get in moles. Now, what we used in the last video, mole ratio, comes into play in step 4. We use the mole ratio to go from the moles of one chemical to the moles of the unknown chemical that we're trying to find. And our last step, number 5, is get the desired units. Often it'll be mass, that's probably the most common, but it could ask for a concentration or a volume. So those are steps. Now for an example. So we've got 150 grams of potassium chlorate. It's breaking down, and we're interested in the oxygen. So we're going to need to start with a balanced chemical equation, and then we're going to write out our information. There's our balanced chemical equation. 2 to 3. Now some of you are going to say, what if I put down 1 and 1 and 1.5? It'll still work out the same. So it doesn't matter as long as it's balanced. So we're told in the question we've got 150 grams potassium chlorate, and our unknown is the oxygen. So what we're going to do is we're going to try to get to moles of this, use a mole ratio to get moles of that. Once we have moles, then it's a simple conversion to mass at the end. So here are the arrows for our roadmap, and we always have to write in sidings. So we have mass here, moles. Moles is where we can move from one material to another. So we've plotted out our roadmap, and you can see it's 3 steps. So this is coming in again. So we take our 150 grams, we divide by the molar mass of potassium chlorate, and we get our moles of potassium chlorate. I don't write the potassium chlorate here, it's underneath it, so I know what it is. It's a bit like accounting. Now I should have an arrow coming across. And we're going to use our mole ratio, and we can see we're going to multiply by 3 and divide by 2. So that'll work, or you can simply multiply by 1.5. So there's my mole ratio of 3 over 2. The moles of potassium chlorate cancel out, and it comes out in moles of oxygen. So I end up with my 1.84 moles. And I've chopped here for writing down the example, but on the calculator, I just leave the digits in there. And the last step is where I'll chop officially. Now I have to get the molar mass of oxygen. I don't care about this 3, I don't care about that 2. I only deal with the coefficients in the mole ratio. All I care about is O2 has a molar mass of 32 grams per mole. Multiply out, and I get 58.8 grams. So stoic takes up room. You have to give yourself room. I expect to see it spread out. You don't bunch these things together. Give yourself room, spread it across the page. Spread the sidings out. They should be written down. If you don't show the work this way, you don't get the marks.